Okay, we're going to do one more example of implicit differentiation, this time to find a second derivative. We're going to be looking at the circle equation that we had before, x squared plus y squared equals 16. And we're going to start by finding just the derivative. Okay, so we have x squared plus y squared equals 16. Differentiating the left-hand side, we have 2x is the derivative of x squared. And to differentiate y squared, remember, think chain rule. We differentiate our outside function and evaluate it at the argument. That gives us 2y. And then we want to multiply by the derivative of y. dy dx. On the right-hand side, we're differentiating the constant 16. And so we get 0 out. Next, we're going to solve for dy dx. So I'm going to subtract 2x over to the other side. Whoopsie. So we have 2y dy dx is going to be equal to negative 2x. Dividing through by 2y gives us dy dx equals negative 2x over 2y. And so we can simplify this down to negative x over y. All right, and so dy dx is negative x over y. Now, if we want to take a second derivative, the second derivative is just the derivative of this derivative. So this is d dx of dy dx. And so what we can do is differentiate this expression negative x over y. Notice this is a quotient, and so we are going to use the chain rule to do this derivative. Let's try this out. We differentiate the numerator, so we have d dx of negative x times the denominator, y, minus the numerator, negative x, times the derivative of the denominator, y, all over y squared. Okay. And you'll notice that here we actually had an expression for the thing that we were trying to differentiate. And so even though it has x's and y's in it still, there's no algebra that really needs to be done. We still have a little bit of differentiating to do. The derivative of negative x is going to be negative 1. So this is negative 1 times y. Here we have minus negative x, so plus x. And we're going to just write dy dx for the moment. And this is all divided by y squared. Okay. I want to remind you that we actually have a formula for dy dx. So we can just plug that in. So d squared y dx squared. So this is the second derivative of y. Is going to be equal to negative y plus x times negative x over y. And this is all over y squared. We can simplify this a little bit by multiplying both sides, top and bottom, by y. So this is negative y squared minus x squared over y cubed, or negative x squared plus y squared all over y cubed. Okay, so we only have to do this like implicit differentiation on the first level of derivatives. Once we have that, we can use something like product rule or quotient rule, as well as the derivative formula that we found to find our higher order derivatives. Okay, great.